Okay, so the last thing we're going to do today is called partial fraction decomposition. So partial fraction decomposition is where you write a rational expression, okay, as two separate fractions. Okay, so these are the steps here, okay, but I'm going to actually walk you through it, and I think it'll make this a whole lot quicker, a whole lot easier to understand, because right now we're just talking about factoring and then linear factors and quadratic factors. Okay, so let's walk you through the steps, and it's going to make it a whole lot easier for you to understand. This is really not too difficult once you get the pattern down, just like solving systems. Okay, so let's take a look at this first one. Okay, so the very first thing that we always do is we factor the denominator. Okay, so step one, we're going to factor denominator. All right, so our denominator here breaks up to x, let's see, minus 3 and x plus 2. Okay, so step two, we're going to rewrite this. Okay, because we have two factors down here, we're going to have two different fractions, each with the separate factors in that denominator. Okay, that's all I've done so far. But now notice we're adding these, so now we're going to have to get a common denominator. So our common denominator would be this times this. So in order to get a common denominator, I have to multiply this by x plus 2, and whatever I do to the bottom, I have to do to the top. And same thing here, so I'm going to multiply by x minus 3, and I'm going to multiply by x minus 3. All right, so now we have x plus 2a, so I'm just going ahead and distributing that a, okay, plus bx minus 3b. I'm not going to worry about the denominators anymore right now. Now I'm just going to look at the numerators. Okay, I'm going to go on ahead and I'm going to take an x out wherever I can. So I can take an x out of this, and that leaves me with x times a plus b. Okay, and then this one leaves me with 2a minus 3b. I can't take anything out of those two terms. All right, so now I'm going to write a system of equations. So I know that my x piece is a plus b, so a plus b, and I'm going to set that equal to my x piece in my numerator there. So my coefficient is 1, so that's what I'm setting it equal to. Now I'm going to do the same thing for this piece. Okay, so this is my constant piece, so 2a minus 3b equals, so I'm going to set it equal to my constant in my numerator there. Now I have a system that I can solve. Okay, so I'm going to go on ahead and solve this however I can. In this case, I can solve for a or b first. So a equals 1 minus b. And then I'm going to use substitution and plug that back in here. Okay, so now I'm going to get 2 times 1 minus b minus 3b equals 7. So now I'm going to get 2 minus 2b minus 3b equals 7. Subtract 2 from both sides and combine my like terms, and I get negative 5, not x, negative 5b equals 5. So b equals negative 1. Okay, so now I know what my b is. I'm going to plug that back in here, okay, and I'm going to get my a value. So a equals 1 minus negative 1. So a equals 2. And now to write this as an addition problem. So now I'm going to refer back to that piece right there. So I know what my a is. So that's a 2 over x minus 3 plus my b value, which is a negative 1. And you could just write minus 1 over. Okay, but I just prefer to do it this way. And then that's going to be over x plus 2. Okay, so that's my answer. So now really what happens is if I were to multiply this out and get my common denominators and add these back together, I would wind up with that up there. All I did was I broke it apart into an addition problem or a subtraction of fractions. That's why it's called partial fraction decomposition. Okay, because I'm breaking it apart into its individual fractions. Okay, let's take a look at this one. Okay, so step one, same thing. I'm going to go on ahead and factor this denominator. Okay, well, the first thing I have to do is pull an x out. So I'm left with x times x squared plus 2x plus 1. So that breaks down to x, and then x plus 1 times x plus 1, which is really x times x plus 1 squared. All right, so this one is going to be special. Anytime you have like squared or a third or a fourth here, you have to include every single part of that. So let me explain what that means. Okay, so up here I have an A, a B, and a C. So my first one is going to be A, my second one is going to be B, and my third one is going to be C. So anytime I have something greater than just a factor, in this case an x plus 1 squared, I have to start with x plus 1. Oh, I can write it. Okay, x plus 1, and then my next one would be x plus 1 squared. If this was an x plus 1 to the third, then I would have plus d over x plus 1 to the third plus e over x plus 1 to the fourth. Okay, so it would keep going. All right, so now we have to do the same thing we did on the last problem. We have to find a common denominator. So in this case, I have to multiply times x plus 1 squared, because that's my common denominator. How do I know that? Because that's the common denominator I found when I factored this. Okay, so in this case, I just have to multiply this times x and times x plus 1. Okay. And in this case, I just have to multiply times x. Okay, so I'm going to go on ahead and see, whatever I do to the bottom, I have to do to the top. So I'm just writing it down so you guys can remember that. Okay, so I'm going to go on ahead and do x plus 1 squared. So x plus 1 squared is x squared plus 2x plus 1. Okay, so I have a x squared plus 2ax plus a. Okay. Now I'm going to do my b piece plus b times that is, so this one right here, if I multiply that, that's x squared plus 1x. Okay, so that's going to be bx squared plus bx. Okay, and then I'm going to have my c, which is just cx. Okay, so now I have to break this apart again. So I'm going to look and I'm going to find anything that has an x squared in it, and I'm going to pull out an x squared, and so that would be just a plus b. So really what I'm doing here, let me back up in case you didn't catch it on this last one, in case you didn't understand. So really what I'm doing is I'm grouping these together. So I'm going to rewrite this whole function so that my x's, my constants, and my x squareds are together. So I just rewrote this, ax squared plus bx squared plus 2ax plus bx plus cx. So anything that has an x term in it. Okay. And then I'm going to write my constants. Okay. So now all I'm doing is I'm factoring something out of this. I'm finding the greatest common factor. So x squared is what these have in common. Okay, so that's an a plus a b times x squared. This one right here, they all have an x in common. And that leaves me with 2a plus b plus c. Okay, and this third one is just the a. Okay, and sometimes you'll have more than just an a, sometimes you won't, it depends. Now I'm going to write my system. So I'm going to go on ahead and start with my a plus b. And there's an x squared, so I'm going to set it equal to my coefficient for my x squared that's in my original rational expression. Okay, now I have my x part, so my 2a plus b plus c is going to be set equal to 20, because that is my x part here. And then my constant a is going to be equal to my constant in my rational expression. Okay. Now I have a system I can solve. All right, so I know a equals 6, so I'm going to go on ahead and plug that in here. So 6 plus b equals 5. So that means b has to equal -1. So now I've found a and b, now I can solve this last one. So 2 times 6 plus -1 plus c equals 20. So 12 minus 1 plus c equals 20. 11 plus c equals 20. So c has to equal 9. So now my answer is going to be written as a bunch of fractions added together. And this is where I have to take these denominators. Be careful that if you had a over x, that you put the a value over the x value. Okay, so that's going to be 6 over x plus my b value, which is -1 over x plus 1. And then plus my c value, which is 9 over what I had it over here. Okay. And that's my final answer. Okay, so that is partial fraction decomposition. And you will have to use that also in calculus. That's why I wanted to go over these with you guys. Have a great day.